Hi guys, I hope you are all doing well. Let's see today's question. So today's question we are taking this up from the topic of permutations and combinations. And if I talk about the question that is given to us here, the question tells us to find how many integers between 100 and 1000 are present with the condition that says that sum of the digits that are present should be equals to 14. So that we have to figure out how many number of integers are present between 100 and 1000. So basically we have to find out how many 3-digit integers are present between 100 and 1000. So all number of 3-digit integers we have to find out except 100, where the sum of the digits becomes equals to 14. And if I see how to solve this, let's understand how to solve this further. Before starting off with the solution for this question, I would first like to tell you that please do subscribe to my channel and support the channel as well, because it takes lots of efforts in making these videos for you, and it is free for you but also motivates me to put up better content and try to make the solutions as easy as possible. So let's try to solve this question. So let's say I have to form a 3-digit number, and let's say that 3-digit number is ABC, right? So this basically denotes my hundreds digit, this B denotes my tens digit, and C denotes your units digit. Now, when I have to form a 3-digit number, one thing is very clearly understood, that the first digit A cannot be 0. It can be anything but greater than or equal to 1. So let's take an example. If I take, let's say, a number which is 077, right? So now if you see A is 0 here, but does that turn 077 into a 3-digit number? No, right? It's a 2-digit number. So I cannot include this in the list. So I understand one condition, that A should be anything but greater than or equals to 1. And the other idea they have told me here is the condition should be always followed, that the sum of the 3 digits A plus B plus C should be equals to 14. So let's try to figure out how many total integers would be present, which are 3 digits, and also the sum of them should turn 14. So first case I can do here is, let's take all digits are same. So if all digits are same, means A plus A equals 14. So that basically makes it 3A equals 14. And I know A, B, C, whatever they are, they should be any integer value, and all of the three should be anything from 0 to 9, where A cannot be 0, but B or C both can be equal to 0. So A should be anything greater than or equal to 1, but B and C can be 0, but A, B, C, all the three of them can hold any values from 1 to 9, right? Because it's representing every digit. So it cannot be more than 9 as well. So if I see 3A equals 14, so A becomes 14 over 3, which is not an integral value. So I cannot have any integer in this case where all digits are same. So one thing is that there is no integer in this case. So zero integers for this case when all the digits are same. Let's take case 2. So case 2, if I take, let's say 2 digits are same. So any 2 digits can be same. So let's say A plus B plus C was 14. So let's say A and B are same, or B and C are same, or A and C are same. So any two out of the three are X, let's say, and the other is Y, which is not same. So it basically makes it 2X plus Y equals 14. Now, when I write X and X instead of A and B, it does not only represent A and B. It basically represents a general idea that any 2 digits are same out of A, B, and C, right? So 2x plus y equals 14. Let's see how many integers first of all satisfy this condition. So if I put x as, let's say, 0, what do I get? 2 into 0. So y becomes 14, right? So if I put x as 0, y becomes 14. If I put x as, let's say, 1, I get y is 14 minus 2, which is 12. If I put x as 2, I get y as 14 minus 4, which is 10. If I put x as 3, I get y as basically 14 minus 2 times 3 is 6, so 8. Then further, if I write this list, I can write also x as 4. So 2 into 4 is 8. Y becomes 14 minus 8, which is 6. Then if I take 5, 10. 14 minus 10 is 4. Then if I write 6, 12. Y is 14 minus 12, 2. And the last, if I put x as 7, y becomes 0. So I get all of this list for the different values of x and y that are possible. Now, once I write them as x and y, we know x and y represents the digits that are used for ABC. So they cannot be greater than 9. So this 3 are already eliminated. So in total, I have 5 possible combinations. Out of this 5 possible combinations, if I see 3 and 8, 4 and 6, 5 and 4, 6 and 2. This 4 combinations, if I see, every combination I can write them how many times. So basically, if I want to write a 3-digit number with 3 and 8, I can write this as 383, or I can write 833, or I can also write that as 338, right? So basically, every number I can write it 3 times. So every number, if I can write 3 times, total how many 3-digit numbers I can form with this 4 is 12. And from 7 and 0, if you see here, 7 and 0, if I use, I can write this as 700, or I can write this as 770. But I cannot write 077, right? So this cannot be done. So when this cannot be done, I understand that because it's a 2-digit number, I have to form a 3-digit number. So in this case, I can only have 2 cases possible. So in total, 12 plus 2, I can just form 14 3-digit integers with the condition that 2 digits have to be same here, right? So from this, I get 14 cases possible. From the previous case, when all the digits had to be same, I get no integer satisfying that. Now, if I just do the third case wherein it says that all the digits are different, let's see how to solve that as well. So case 3, where all the digits are different now. So if all the digits are different, let's see. So we had a condition given to us that sum of the 3 digits has to be 14. And since all the digits are different, I can just replace ABC as X, Y, and Z. So I know that sum of this 3 x, y, and z has to be 14. Now x, y, and z can represent any one out of A, B, and C any respectively. So x can represent A, then y can B, and z can be C. X can also represent B, then y can be A, z can be C. Anything is possible. So any order is possible. So if I try to have the greatest possible value for x, I can have that as 9. So if I have x as 9, in that case, y plus z becomes 5. If y plus z becomes 5, let's try to have all the intervals I can have. So I can have 9 as x, and y plus z being 5 can be when 5 and 0 is there, or I can have 5 when 4 and 1 is there. I can have 5 when I add 3 and 2 also, right? So these are the different types of combinations I can have, because if after that I can have 2 and 3, but that is already possible made in this combination. So 932, I can arrange them and get them 923. So this is not counted. So we are just trying to make out how many different numbers I can have. Then we'll see how many combinations we can make with them. So otherwise, x, if I put, let's say 8. So if I decrease x by 8, y plus z in that case becomes 6. So with that, if I try to make out different combinations, I can have 8, 5 and 1. With 8, I can also have 4 and 2. With 8, I can also have 3 and 3, but 3 and 3 basically makes 2 digits same, which we have already accounted for in the previous case. So this also does not satisfy. I also can have 8 and y plus z is 6. So I can have 6 and 0 as well. So this combination is also possible. Now, if I decrease x with one more, I get x is 7. Y plus z in that case becomes 7. So if I try to figure out now what I can do here is 7. So if I want 7, I can have 7, 0, but that's also accounted for because 2 digits are same. 7, I can also have 6 and 1. With 7, I can also have 5 and 2. With 7, I can also have 4 and 3. So here also three combinations are possible. With x equals to 6, y plus z in that case becomes 8. So if I see for that 6, I can have 8 and 0. But if you see 6, 8 and 0 is already accounted for in this. So this I have to cancel because this is not showing me different type of combination. 6, I can also have 7 and 1, which is also accounted for 6, 7 and 1. With 6, I can have 5 and 3, which is not accounted. With 6, I can have 4 and 4, but that's making two digits same. So everything after that will be a repetitive thing. So we don't need to account for anything less than 6, because if I put x as 5, y plus z becomes 9. So 5, 9 and 0, 5, 8 and 1, 5, 7 and 2, 5, 6 and 3, all of them are accounted for. So we don't need to account for anything else after that because it will make it repetitive. So in total, we have 10 unique cases. Now let's try to form the 3-digit numbers with this 10 unique cases. So if I have in total 10 cases here, let's analyze those 10 cases. So if I analyze those 10 cases, first of all, I'll analyze the cases without zero. So the numbers without zero, this three, and this. So basically in total, I have this 8 different cases, right? So if I have, let's take an example. If I have 941, 941, I can arrange those 3 different numbers in 6 different ways. So basically, I can arrange these 3 different numbers in 3 factorial ways. So in total, when I had 10 cases, 8 were without zero, and 8 of these cases, I can arrange each of them in 3 factorial ways. So that gives me 8 into 6, which is 48. So I can arrange them in 48 ways. And the remaining 2 cases, which is with zero, the remaining 2 cases, which is with 0, 950 and 860. So these 2 cases, if I see, for that 950, if I see, I can arrange that also in 6 ways. So if I arrange them in 6 ways, let's do that. What I observe is for the first digit 0, it does not form a 3-digit number in 2 cases. So out of 6, 2 are neglected. So those 2 cases, I will multiply them with 3 factorial. But that out of 3 factorial means out of 6 cases, 2 do not satisfy the condition of being a 3-digit number. So I should subtract 2. That gives me 2 into 6 minus 2, which is basically 4. So I get here 8 possible numbers for the remaining 2 combinations with 1 0 in them. So in total, I get 48 plus 8, 56 3-digit numbers with a condition where all the digits are different. So in this case, I get 56 3-digit integers. So in total, now if I see with all the 3 cases, so for the first case where all digits were same, so when all was same, I got 0. When 2 digits were same, I got, in that case, 14 3-digit integers. And where all of them were different, in that case, I got 56 3-digit integers. So in total, I got 56 plus 14, that is 70 3-digit integers that were satisfying the condition where sum of the digits was becoming equals to 4. So that's how you solve this. I hope you have understood how to solve this type of questions, which deals with the ideas of finding the number of integers between any list that is given to us with a condition. I'll see you again tomorrow with some other question from some other topic. And we are going to continue our series of questions on JEE mains. So stay tuned for more videos to roll out. Also, if you're enjoying these videos that we are doing on everyday basis, please do like the videos as well, and do comment on the videos and share these videos with your friends also who are involved in the preparation of questions on JEE. So they can also take the benefit from these questions that we are solving on everyday basis. Thank you.